P2, the Cartesian coordinate system.
Were we supposed to have done the note video for P2?
Yes.
Yes. Where were you when I just checked them?
He
knows you didn't do it.
was asking because he did it and he was just making sure.
I just didn't do it.
He just wanted to make sure that he wasn't ahead.
I forgot how this note.
As if this wasn't the entire last year of what we did. Yes, you were supposed to have done them for today. Okay. First one, name the quadrant containing the point. So this is just like what part of the quadrant it's in, or if it's on an axis, then we're going to state what that is. So I'm going to go ahead and write all 4 points, and then we'll just say what they all are. So the first one is 1/2 and 3/2. Then -2, 0. -1, -2. And 3/2, -7/3. So what quadrant is point A in on our graph, where both things are positive? 1.
Wait,
Both are positive, so it's 1, 2, 3, 4.
Sucks.
No, I don't want you to solve it. Okay. How about B?
X-axis.
Yep, it's on the x-axis. C? Third quadrant.
Yes. Yeah.
And D?
Fourth.
Yep. Let's see. Evaluate the expression. So dealing with stuff that has absolute values in them. So 6 is 2 minus, in the absolute value bar is -2. So what happens to something in absolute value bars?
It becomes positive.
Yep, becomes positive. So this is going to be 2 minus 2, which is just 0. Eight, -2 over the absolute value of -2. What is this going to give me?
-1.
-1. This top's negative, bottom will be positive. Rewrite the expression without using absolute value symbols. So, these ones are kind of weird. It's the absolute value of the square root of 5 minus 5/2. So basically when we have one like this, we just flip the two numbers so that way their signs change. So this is just 5/2 minus the square root of 5. Would be like what that's equivalent to.
So why does the square root of 5 become negative? Sure, I knew this at some point.
Basically because the square root of 5 is smaller than 5/2.
So you just subtract.
So yeah, so it's basically just showing you what this would be equal to. We're just
Okay.
not actually solving out
Okay.
the number. Because like one of the other ones is like pi minus 5, and so it becomes 5 minus pi because it's just like subtracting it so that you see what the answer would be.
If the first number was bigger than the second number though?
We wouldn't do anything to it. It would just stay the same. We're just rewriting it so because in this situation we're going to end up with a negative answer. By doing it this way we end up with the positive answer because absolute value makes it positive. So it's just kind of weird. You're not likely to have one like that on a quiz because it's just kind of annoying. Okay, so the next ones are distance problems. So obviously we can just have two like numbers like on a number line and we can have to find the distance between them, Or we can have two coordinates and we need to find the distance between the 2 points on a graph. So the one that is obviously the easier one is if we just have a number line. So something like 12 where we have -5 and -17. We just do the absolute value of one of them minus the other one. It doesn't matter which one's listed first because they're an absolute value. It's going to become positive either way. So this would be the absolute value of -5 minus -17. So that ends up being just 12. So those are like the easy ones. Can somebody tell me what the distance formula for 2 points are? Like 2 coordinate points.
The square root of x1 minus x2 squared plus y1 minus y2 squared.
Yep.
It's just Pythagorean.
And it doesn't matter if you swap the x1 and x2, which point is which one. It doesn't matter as long as your x1 and your y1 are coming from the same point and your x2 and your y2 are coming from the same one. So 16, we've got -1, 2, and 2, -3. So the distance is equal to the square root of
-1 minus 2 squared plus 2 plus 3 squared.
Yep, because minus negative and plus. Good. So then this would be the square root of 9 plus 25, right? Yeah. Square root of 34. And we can just leave it like that for our answer. I'm not going to do another one of just finding the distance because we're going to use this to solve another problem. So we're still going to be using the distance formula to get a little bit more of a refresher. But that way we're not having to do like 8,000 problems of this. So the next set of problems say to find the area and perimeter of the figure determined by the point. So basically you're going to have 3 or 4 points. Could make a triangle, square, rectangle. I don't think any of them give you a super weird shape. I think they're all one of those, but if they do, then just, yeah, we'll have to figure out what the formula is for it. But I think they're all either rectangular or square or triangle. So basically we're going to plot the points and then we're going to figure out, we have to find the distance between each. Now, if we know that it's a square or we know that it's a rectangle, obviously I don't need to find all the sides. I just need to find 2 of them. And then we'll be finding the perimeter and area of those shapes. So 20, I've got the point -2, -2, -2, 2, 2, 2, and 2, -2. So I would label each of these with a letter. So I do like A, B, C, and D. Whatever letters you like to use is fine. And I'm going to be finding the distance between each of these. But first, I'm going to put it on a graph and see, just by looking at it, do you have any idea what shape this is going to be?
Square.
Yeah, they're all the same number, so pretty much has to be a square. But I'm just going to quickly plot these 4 points just to have it for the visual. So let's see, this is A. And if you want to connect them to actually make your square, you can. If not, that's fine too. All right, so since it's a square, I only need to find one of the sides, right? So I can just do the distance between. Now, I also understand that if you graph it, do we really need to use the distance formula? No.
If they were going horizontal.
Right. As long as they're vertical or horizontal. I want to say one of them takes the square and like skews it so it looks more like a diamond. So you'd kind of have to do it this way or by using the distance formula. But we can see that this is just obviously 4 units. So I'm not even going to do the distance formula on this one. I'll do it on the next one. So the distance from, we'll just say B to C is 4. What is the formula for perimeter of a square? Let's see if we remember from geometry. Not perimeter.
4 times the side.
Yep, 4 times the side, which in this case is essentially like it being squared. But so 4 times 4, so the perimeter is 16. They don't give us units, so we don't have to worry about it. And then Zach, what's my area formula?
Side squared, so.
Yep. So it'll end up being the same thing for both of those. 22, -2, 1, -2, 6, 4, 6, and 4, 1. Do we know what shape this one is just by guessing?
Rectangle.
Yep, probably a rectangle. Put it on here and just to confirm. So I've got -2, 1, -2, 6, 4, 6, and 4, 1. So labeling them again. So because this one again is still horizontal and vertical, I could count and figure it out, but I am going to do the distance formula just for make sure we got it down. So the distance from A to B, and I usually just will do the little letters like that so that I show which one I'm finding, would be the square root of -2
+2 squared plus 1 minus 6 squared.
Shepard's got it down. So then that ends up being, well, that's 0 there, and then this is just -5 squared, so 25. So square root of 25, which is 5. And then if we do the distance from B to C, somebody besides Shepard want to do this
4
one?
minus 4 squared.
You got it wrong.
Well, the square root of
BC.
6.
Are we doing BC or CD? Wait.
BC. So 4 minus, so +2 squared plus 6 minus 6 squared. So square root of 36, which is 6. All right, now what's the formula for perimeter of a rectangle?
Side
2
plus
side plus 2W.
Yep, 2L plus 2W. So I've got 2 times 6 plus 2 times 5, 22. And what's the formula for area of a rectangle?
30. Side width, length width.
Length times width. And as you said, it will be 30. Now, with a triangle, obviously it has 3 side lengths, but when you find the area of a triangle, what do you have to have?
Half the base and the height.
Yeah, so you need the base of the triangle. So there would be an advantage to plotting those points because then you can just do the base and then you need to find the height of the triangle. If it's like crooked, then obviously you're going to have to find the distance from the center of the base, so the midpoint of the base to the tip of the triangle. But if it's straight up and down, like how these ones have been, you can just count your height so that you can do that. So even though there's only 3 sides, you still may potentially have to do 4 distance formulas. Some of you look confused. Good?
Mm-hmm.
Okay. finding the midpoint of these. So basically, they, I think pretty much, no, they didn't. I lied. Never mind. Disregard what I was supposed to say. To find the midpoint of just two numbers, what do we have to do?
A minus B over 2.
Yep. Well, plus. Yeah, but yes. So we have the points -5 and -17. So just the two numbers. So we're going to add those together. -5 plus -17 and divide by 2.
11. -11.
Yep, -11. So the midpoint of those would be -11. What is our formula when we have two coordinate points?
A plus C over 2 and B plus D over 2 in order pair.
Yep. And this is where it would be like AB and CD would be our two ordered pairs that we started with. So if they gave us 5, -2, and -1, -4, what would I be putting in here?
5 minus 1. Wait,
Yep.
Wait, why would it be?
Over
Oh,
2.
yeah, 5 minus.
and then -2 minus 4 over 2.
Yep. So since these are negative numbers here, that's why we're just saying minus, but obviously it's technically plus a negative. So then we've got 2 and -3. So that would be our midpoint of that line. Any questions on that? All right, the last thing in this section is a kind of like stats problem. So it's to draw a scatter plot of the data given in the table. So when you do it, you don't have to copy the table over. I'm going to just put it up here for right now. But basically we have an XY table. And they give us the years from 2001 to 2007, and then the population, or what is it? The total number of motor vehicles produced in the world each year. And then we're just going to make a scatter plot with it. So basically we're just graphing the points in quadrant 1. So in 2001, there was 57,705 vehicles. 2002 is 59,587. 2003 is 61,562. 2004, 65,654. 2005, 67,892. 2006, 70,992. And then 2007 is 74,647. All right, so basically we're going to make a little scatter plot. I think we did these last year, maybe just on your calculator, or just, I don't know. I don't even remember what we did. Anyways, but basically we're just gonna set up a little graph here. We're gonna have our years down here. So from 2001 all the way up to 2007. Close enough. All right, now, because I start at the first quantity of cars or number of vehicles that were made, that at least in what we're looking at is 57,000. I'm going to do the little squiggly line thing that basically says I'm skipping a bunch of numbers, and then I'm going to start at 55,000, and I'm just going to write a K to represent thousand. And I'm going to go all the way up to 75,000 because I'm just south of that. So I'm just gonna count in 5,000s. I kind of smushed those together, but that's fine. And then we want to make sure we put labels. So this is the number of vehicles basically made in that year. And then we're literally just plotting these points to make our scatter plot. Normally scatter plots have a lot more numbers on them than these, but these are just kind of basic. So in 2001, we're up at 57,000, so about halfway between. 2002, we're almost at 60. 2003, we're a little over 60. 2004, 65, over 65. 2005 is at 67. 2006 is up at 70. And, oh, that's too high. 2007 is almost all the way up to 75. So it doesn't have to be perfect in this, because obviously I'm just doing it by hand. It kind of looks linear. If we did it in the calculator, it may or may not look that way. But anyways, any questions on that? Okay. Alrighty, then problems are um 1, 3, 7, 13, 19, 23, 20, whoa, that's not bad, 25, and 29. So if you finish these and you want to work on the notes for the next section, you can do that after you do this. Okay, good.